Alright, so today we're covering section 3.1, the Cartesian coordinate system. So we're going to talk about the Cartesian coordinate system, graphing equations, distance and midpoint formulas, and using the distance and midpoint formulas to solve problems involving triangles. The Cartesian coordinate system, or rectangular coordinate system. So in this Cartesian coordinate system, the horizontal line is called the x-axis, so it's right here. And then we have the vertical line is called the y-axis, right here. And then the point where the axis meets, the plural of axes, intersects called the origin. So right here, this would be the origin. It's the point 0, 0. And you normally number off in the natural way, 1 unit, 2 unit, 3 units. Moving to the right is positive, moving up is positive. So this is our positive first quadrant, our second quadrant where the x is negative, our third quadrant where the x and the y's are negative, and the fourth quadrant when we have our x coordinate positive and our y coordinate negative. And we move in a counterclockwise fashion when naming the quadrants. So plotting points, like the alphabet, you do the x-coordinate first. So each point in the plane corresponds to a unique ordered pair, A, B. The first coordinate A is the x-coordinate. The second coordinate B is the y-coordinate. So if we plot the point 2, so let me use the same colors I used before. So horizontally, we move 2 units to the right. So 1, 2 units, and then 4 units up. And that'll give us a point 2, 4. Now, normally we don't draw these lines right here when we just plot the point. We don't actually draw the lines when we're plotting the point. So, the solution set of an equation in 2 variables, x and y, consists of all the ordered pairs of the real numbers x and y that satisfy the following equation. The graph of an equation consists of the solution set of the equation plotted in the Cartesian plane. So remember when we're solving for when we're just solving for one variable, like we had, like we had our equation ax plus b equals c, and we'd solve it and we'd get x equals an answer. Well, we'd get one answer, whatever it be. We get this one answer right here. Now, if we have x and y, well, there's a whole bunch of numbers that would satisfy this. So the only way to describe all those numbers, like before when we were in one variable, we only get one solution back out, unless you're talking about some kind of inequality or absolute value. But when we have a linear equation in 2 variables, there's a bunch of numbers that you can get back out to solve the equation, infinite number. And the only way you can represent those is with a line. So for examples here, it says graph the equation. And so they give us the equation in exercise 1 as y minus 5x equals 2. So it says we want to plug in 0 for the x and see what we get back out for the y. So for this first one right here, I'm going to go off to the side and I'm going to say, let's do it right down here. Y minus 5 times 0 equals 2. This is when the x equals 0, because it asked us to put in 0 for x. And then that's going to give us y equals 2. So this is the point 0, 2. So that means I'm going to go up over 0 and up 2. So I'm going to be right here on this point. The next one, it asks us to plug in 0 for y. So that would give us 0 for y minus 5 times x equals 2, so that's negative 5x equals 2. So for this next point right here, when it said plug in 0 for y, we're going to get x equals 2 over 5, and that's a negative 5, so it makes the whole thing negative. And so with this here, if we have the point negative 2 over 5. It's a fractional point. We don't like to graph fractional points if we can avoid it, but this is our x-intercept, so that means that we go over to negative 2/5, which would be right here, up 0, so that's this point right here. And then it's always good to graph a third point just to make sure. 2 points determine the line, but a third point you can use to check it. And so something you might use, you'd want to plug in something easy. So here, the 5 is the coefficient of the x is 5. It's not 1. So it'd be easier to plug something in for x than y, because y has a leading coefficient of 1. So I might plug in something like, let's say, -1 for 5. So if I plug in -1 for 5, or sorry, -1 for x, I'll get x equals -1, and so that will give me y minus, and then I'll have 5 times -1 equals 2. So that's going to give me y plus 5 equals 2. So y equals 2 minus 5, which is going to be -3. So this is going to be the point -1, -3. And I picked that point. You can graph a lot of other points. This is just another point, a nice whole number point that ends on this graph. If I were to graph some other point, like if let's say, you could plug in something like, you could say x equals, something like 10. You'd get a number way off this graph. It would be like in the 50s or something like that. Positive, yeah, if you plug in 10, it would be off this graph somewhere. It'd be up here somewhere, well, way up here actually, way off the page. But you try to pick numbers close to 0, keep your points, all together, and then you draw a line connecting all those points. And every point on this line is a solution to this equation. Every single point. And there's an infinite number of points. So I just can't write a list of ordered pairs down. Now when you write these ordered pairs, normally since it's in this column situation, you normally write these ordered pairs with parentheses and say 0, 2. That would be, this would be -4/5, 0. And this last point we have would be -1, -3. Now a lot of times Hawks gives you the parentheses, so you don't have to write those down. But if you're writing them down in your notes, make sure you put those points in parentheses to let people know it's a point. Here, the second exercise, they give us another graph of one. I need some extra paper for this. So they give us, they want us to graph an x squared plus a y squared equals 16. And so they give us a bunch of values to plug in. And the first they say, well, try when you plug in 0. It's always, plug in zeros, make one of your variables zeros. It may make it easier to solve. Let's see if that works. If we have x equals 0, then that's going to be 0 squared plus y squared equals 16. And so that gives me y squared equals 16. And if I take the square roots of both sides, I'm going to get y equals, remember when you're solving for an unknown, that's when you're going to get your plus or minus of your square root, which is this plus or minus 4. So here, in shorthand notation, I might put plus or minus 4 to let me know that I could get, if I plug in 0 for x, I could get -4 or +4. But if I were to write these as coordinates, I'd want to write them as 0, -4 and 0, +4. Now, in Hawks, if you have multiple solutions to exist, you only need to identify one of them. So I could put, for this answer blank in Hawks, you could just put in the positive one or just the negative one. You don't need to put plus or minus. All right? It just needs one solution that makes that number true. Just one y value that when I get back out when I plug in 0. When you have the linear equation like we had before, you only have one value back out, but this is a quadratic equation. It's a circle. Every time you plug in one point, you get 2 possible points back out. And we can see this when we plug in. It's very similar for y equals 0. So y equals 0 is going to give us x squared plus 0 squared equals 16, and very similar. X squared equals 16, so we take the square root of both sides, and we get x equals plus or minus 4, plus or minus 4. And once again, that's going to correspond to the 2 points, -4, 0, and 4, 0 for these two. And so that's going to give you this point, -4 over, 0 up, 4 over, 0 up, so you get those 2 points. And we can see that we're just going to have, since we're on a circle, every time we plug in an x value or y value, we're going to get 2 points back out. Another one here. So we say let x equal -3. Then we're going to get -3 squared plus y squared, and that -3 in itself needs to be squared. I need to put parentheses around it. So I square out that -3, equals 16. So then that gets me what? 9 plus y squared equals 16. So that means y squared. I subtract 9 from both sides, and that's going to give me what? 7. I take the square root of both sides, and that's going to give me y equals plus or minus the square root of 7. The square root of 7 is a fine number. And remember, once you only have to put one of these values in here. You only have to put the positive or the negative version. You don't have to put both in Hawks. And then you could go on and do the same thing for 3, but if we do 3, we'll get the very similar answer. You get, if this was positive, if x equals, let me just do it real quick. So just writing over what I already have. X equals 3. Very similar, you're going to get 3 squared plus y squared equals 16. It's still going to be 9 plus y squared equals 16. So y squared equals 7. So y must have been plus or minus the square root of 7. And so this is plus or minus the square root of 7 as well. And once again, you can write these as 2 points. This would be 3, comma, square root of 7, 3, comma, negative square root of 7. And you see for the blue points here that I could have 3 over negative 7, negative square root of 7 down. This would be 3, positive square root of 7 up top. This would be 3, negative square root of 7 in the bottom. And negative 3, square root of 7. And this would be negative 3 down square root of 7. All right. And so it's good to label your points. This is a circle, so you're going to have a lot of points back out. You may just have something that's, later on we'll learn about quadratics and things of that nature where just one of the terms is squared. But you could definitely get in a situation where you have multiple answers and you only need to put in one. So you only need to put in the plus 4 or the negative 4. You don't need to put in both. Next is the distance formula. So suppose we have A, which is x sub 1, y sub 1, and B, which is x sub 2, y sub 2, are the 2 points on the Cartesian plane. The distance between the 2 points given by the distance formula is D equals, or D of AB equals the square root of x sub 2 minus y sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So basically, it's the Pythagorean theorem. So if you have your x sub 1 and your y sub 1, and over here you have your x sub 2 and your y sub 2, and you want to find the distance between it, you draw a right triangle, and this side becomes the differences in your x's, this side becomes the differences in the y's, and so you just have to take, basically a squared plus b squared equals your c squared, this being your side c, and basically you're solving for c, so that's where that square root showed up. So this would be your side, this would be side a, or little b, and then d would be your c. So this is basically just the Pythagorean theorem. That's all this is. Alright, so it says find the distance between d of ab between A, which is the point 3, negative 5, and B, which is the point negative 1, 8. You could draw this on a graph if it helps you visualize it. Plot out, go out 3, 1, 2, 3, down 5. You'd be over here somewhere. And the point negative 1, so over here, up 8, 1, 2, 3, 4, 5, 6, 7, 8, up here. And so you'd be finding the distance between these 2 points. Right? Distance, or the length of that line segment is another way of putting it. You don't need to draw it. You can just say, I like to label my points so I don't mix them up in my formula. So I'm going to write the formula down. It's always good practice to get into. So the formula is x sub 2 minus x sub 1 squared minus y sub 2 minus y sub 1 quantity squared. Take the square root of all of it. Remember, this essentially is the differences in your x squared plus, I want to put a minus there, plus the difference in your y, the differences in your y squared. So here I'm just going to plug those numbers in. And so I get negative 1 minus 3 quantity squared plus And now I'm going to get, oh, this is y sub 1, excuse me. I'm going to get 8 minus a negative 5. And so that's going to be quantity squared. So that's going to give me a negative 4 squared plus, and so that's going to be what? 8 minus a negative 5, which would give me positive 13 squared. So that's going, I'm going to want to take the square root of that. So I'm going to take the square root of, and then so this is going to be 16 plus, and 13 squared is 169. So that's going to give me what? When I add those two numbers together, I'm going to get 6 and 9. That's going to give me 15. Carry that 1. That's going to be what? 6 plus 6 is going to be, no, not 6 plus 6 plus 1, excuse me. It's going to be 7 plus 1 at 8. So that's 185. We want to make sure there are no perfect squares in there. It's not divisible by 3. It's not divisible by 9. Because if I add up all the digits, it should be divisible by 9. You can always check. Just real quick, you can say 185 divided by 9. Nope. Is it divisible by 25? That would be the next one. And it's not, because it's not divisible by 16 because it's not an even number. But we could check real quick. Divide by 25. And no, it's not divisible by that. And we've already gotten past any other perfect squares when we get that 7.5 back out, or 7.4. And so it doesn't have any perfect squares, so this is just, you leave it like the square root of 185. Don't round it off unless it tells you to approximate with decimals. The midpoint formula. So here we have, suppose that A is the point x1, y1, and B is the point x2, y2, and there are 2 points in their Cartesian plane. The midpoint of the line segment joining these 2 points is given by the midpoint formula, which is m of AB equals x1 plus x2 over 2, and y1 plus y2 over 2. Each of those coordinates, this is going to be x coordinate, this is going to be y coordinate. Remember, the distance only gives you one number back out. The midpoint's still going to give you a coordinate back out. And so basically, the x-coordinate is the midpoint as the average of the x-coordinates, A and B, and similarly for the coordinates of A and B points, and similarly for the y-coordinates. So basically, it's saying the average of your x-coordinates, comma, average of your y-coordinates. So once again, you can draw these points if you want to real quick. You may not have a lot of room on your graph paper, but sometimes people like it because it helps them keep track of things. So negative 9, 1, 2, 3, 4. So it's negative 9 right here, 2 up to this point, and then 10 over, right here, 6 up. Should be over here. This would be 10, 6. This would be negative 9, 2. And we want to find out where the midpoint between these 2 points are. And so I would say midpoint, and I like to label my points, so x1, y1, x2, y2, and I'm going to write my formula down. Always a good habit to get into, to write your formulas whenever you're doing math with them. Helps you remember them. And then once you have that, you're going to say your x1, you're going to have negative 9 plus 10 over 2 for your x-coordinate, and your y-coordinate is going to be 2 plus 6 over 2. And so that's going to give you 1/2, comma, and this is going to give you 8/2. And you want to simplify those fractions when possible. So this will be the point 1/2, comma, 4. So in other words, this point that I'm getting back out, if I were to look this up, I would go over 1/2 right here, which would be right here, and this would be 4 units up. So this would be the point 1/2, comma, 4, which, you know, even though it's not drawn to scale, kind of looks like it should be there, halfway in between. All right, so we want to go over some definitions of triangles because we're going to use this information to help solve triangles. Distance and midpoint. The Pythagorean theorem states that the triangle with the sides of A, B, C, where the angles opposite C is a right angle, then we have A squared plus B squared equals C squared. Note that C must be the longest side. A right triangle is a triangle who satisfies the Pythagorean theorem, because it has to have a right triangle to satisfy the Pythagorean theorem. An isosceles triangle is a triangle in which the lengths of two sides are equal. Scaling triangle is a triangle in which the lengths of no two sides are equal. The perimeter is the sum of the lengths of the sides, and the area can be found by the formula area equals 1/2 base times height, where b is the base of the triangle and h is the height. So in Hawks, they'll ask you a couple ways of solving a triangle. So they'll give you 3 points, and they'll ask you, and it's good to graph these points so you can see whether they are in relation to each other. The perimeter, so we need to find the length of every side and add that up. And they could also ask the area. Usually when they ask you to find the area, though, they either give you a right triangle, so the height is very easy to find, or they'll give you a base right here, and it'll be isosceles. So you know that the midpoint of the base to the top, and you find that distance to be your height, and the base is just going to be the distance from one point to the other. Ignore that part. And so you're going to find the distance of this side, the midpoint, the distance of these 2 points, from the midpoint to the highest point, and then you go half base times height. All right. So let's do a perimeter one. And you can always go through practice and see how they solve it in practice and kind of help guide you through it as well. See more examples other than the ones I just gave in the lectures. So it says, considering the following points. All right, so exercise 5 says consider the 3 points A, which is going to point to the point. So let me draw my X and Y axis here. All right, so A is going to be the point -4, -1. So over 1, 2, 3, 4 units to the left, 1 unit down. That's my -4, 1, -1. My A point. And then B is going to be 1, 11. So up 1, over 1, up 11. So over 1. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so I kind of compressed my y-axis here, so it's not to scale really. And the last point, to make it a triangle, it's going to have to be here, but let's just graph it anyway. Over 1, down 1. So now I'm going to have this triangle, and I'm going to have it looking for a straight edge, something somewhat straight edge-like. That's not going to work. Anyway, so let's assume I could draw straight lines. She's not in this. Oh, I forgot to label these points. So this is B, which is going to be 1, 11. That's B. And C is going to be 1, -1. That's C. Oops, I didn't even go through the point. Let's relabel that as 1. Yeah. I should have had a straight edge ready. Anyway, so this is my triangle, and they want us to determine whether it's not the given points form a right triangle. So it says also find the perimeter and if it's a right triangle. So those are the 2 things we're looking for. So as we can see, it looks like a right triangle, but we need to make sure it satisfies the right triangle definition. So I'm going to need to find a couple distances. So I need to find the distance between A and B. The distance of that, A and B line segment. I need to find the distance between A and C line segment. And then I need to find the distance between B and C. All right, so let's start out with the A, B first. So let's over here write our formula so we don't forget it. This is going to be D equals the square root of the differences of my x's, minus x sub 1 plus y sub 2 minus y sub 1 squared. Take the square root of this. All right, so this first one here, I don't know if I can fit it all in one line, but we'll see. Probably not. So let's say the square root of, and then we're going to have this is x1, y1, x2, y2. And so that's going to give me 1 minus a -4, which will make it +4 squared. And then we're going to have plus 11 minus a -1, which will be positive, so that's squared. So I'm going to get the square root of 5 squared plus 12 squared, which is going to give me 25 plus 144, and I am off the page. I knew that was going to happen. And so that's going to give me a total of square root of 169, which is 13. So this side right here is 13 units long. So next I'm going to go with the distance between A and C. You don't have to really do it in any order. I'm just choosing A again because I already labeled. I labeled C. Oops. That went somewhere. Lesson 2. Find it later. And so I'm going to, let me just do this all in green. So I'm going to get what? Square root of, and so I'm going to get 1, right, 1 again, minus a negative 4, which is plus 4, quantity squared, plus, and now an interesting thing is going to happen is I'm going to have the same y coordinate. So if I have the same y coordinate, that's going to be 0 back out, for my y differences in my y coordinate. So I'm going to have the square root of 5 plus 0, which is going to just equal 5, which we could have just counted. Since it's a horizontal distance, we could just said, you know, this is going to be 5 units over 1, 2, 3, 4, 5. And so that's 5 units. You could have just counted that. Horizontal distance, you can do that for. And then do the last one here. Between the distance between B and C. And like I said, you can just notice that between B and C is a vertical distance. You're going to notice that when you do that, you're going to get your x coordinates are the same, so you're going to get 1 minus 1. And then your y coordinates are going to be, so if your B is your first part, that's going to be, so that's going to be, and it doesn't matter which way order you really do it in, because you're going to square it out. So as long as you get the signs right, you're fine. So I could say 11 minus a negative 1, and that will give me 12. And so I'm going to get the square root of 0 plus 12 squared, which is 12. So the sign becomes 12. And so now, does it satisfy the Pythagorean theorem? Well, we can see that it does because we've actually checked it right here. 5 squared plus 12 squared equals 13. So, you know, 5 squared plus 12 squared equals 13 squared. So that checks out. It's a right triangle. Here's your angle right here. And so it is a right triangle. And its perimeter, so if it wants us to add those together, so it was, we had sides 5, 12, and 13. So the perimeter, oops, I'm writing off the page. It feels like I'm writing off the page. It'll be 5 plus 12 plus 13. So 13 plus 12 is going to be 25 plus 5 is 30. So 30 units, whatever units it's in. And like I said, they can ask different questions. They could ask, like, is a scaling triangle? I mean, it also is a scaling triangle. All my sides have different lengths. But a right triangle is the more important part of that being a triangle. But it can ask you this question a bunch of different ways. Graph it out on graph paper. It's easier to see, easier, especially if you're dealing with horizontal or vertical distances. It's a lot faster to find those just by counting left and right. But if they have different x coordinates, they're not going to be a vertical a nice vertical difference. If they have the same, well, let me put that other way. If they have the same x coordinates, it'll be a vertical distance. If they have the same y coordinates, it'll be a horizontal distance, and you can just count those up. All right, so that's it for this lesson. Hope you all had a great day.